Okay, now we're actually going to solve some nonlinear systems and non-quadratic systems, meaning that it's not going to be entirely linear and quadratic, such as in this case, the first equation is actually the equation of a circle. Second equation is equation of a parabola. So this thing might have up to four intersection points. So I'm going to also show you a little trick here that a lot of times we get stuck on, okay, solve for x, solve for y, and then plug in. So we could actually take y equals and plug it in right here, but we're actually going to end up with an ugly x to the fourth equation. I'm going to show you another thing that you can do. We can actually solve this thing for x squared, because notice you have not just an x, but you have an x squared here. So what I'm going to do, I'm going to take my minus 3 and move it over, and that gives me y plus 3 equals x squared. And instead of plugging it in just for x, I'm going to plug this expression in for x squared. So I'm going to take the x squared out. I'm going to plug in what it's equal to, which is y plus 3 plus y squared equals 16, which actually gives us a nice quadratic instead of a fourth power equation. Now I'm going to put these in order. So I've got y squared first. I'm going to put my y second. I move my 16 over, combine it with my 3, and that gives me minus 13 equals 0. Now, this thing won't factor, so I'm going to go to the Swinford method. Again, you can watch the other videos if you don't remember how to do that. So my coefficients are 1, 1, negative 13, so I'm going to double everything since I have an odd middle number. Left leg is opposite half, right leg multiplied times itself. Head is negative 52 there. So my final answer is negative 1, left leg, plus and minus the square root. Subtract these two. And we get 53, all divided by this number, which is 2. Okay, I've typed those in, and that's my 2. Let's see, that was actually my y values. So I have a y value of, my first one's going to be 3.14, very similar to pi. My second y value, when I subtract, I get a y value of negative 4.14. So now that I've got my y values, we're going to take, and you can plug it into either equation. Doesn't matter which. I think the second equation is going to be a little bit simpler, so let me erase and make myself some room here. So my second equation, instead of y equals x squared minus 3, I now have 3.14 equals x squared minus 3. Move the 3 over by adding, gives me 6.14 equals x squared. Remember, to undo a square, we have to do plus and minus the square root. And that gives me an x value of positive and negative 2.48. So therefore, my first point, actually points, is positive 2.48. 3.14 is what I plugged in for y. My second point is negative 2.48, comma 3.14 for y, because again, I plugged in 3.14 for my y's, and it gave me two different x values. Now what I'm actually going to do, and I bet the same thing happens when I plug in negative 4.14, I'm probably going to come up with two different x values to go along with that. So let's try that. So I'm going to take now and plug in my negative 4.14, and actually something weird happens. Negative 4.14 equals x squared minus 3. When I add my 3 to that, I get actually negative 1.14 equals x squared. To undo a square, I do plus and minus a square root. Square root of a negative actually gives me an imaginary answers, which means that's going to be some answers that we throw out. So that thing's only going to have 2 intersection points. Okay, number 5. That last problem was really difficult, and this one might actually be a little bit uglier than that one was. So again, we're going to make a substitution. Since we have y equals here, we're just simply going to plug that in for y up there. Gives me x squared minus 3 equals x minus 3 over x plus 2. Now, we're not a big fan of the fraction here. So one thing we can do, since that's divided by, we can move it over here by multiplying. But in order to multiply those, we have x squared minus 3 times x plus 2. We're going to have to FOIL that out. That's going to give me x to the third plus 2x to the second minus 3x minus 6 whenever I FOIL it. So now it turns my equation into that equals x minus 3. I'm moving my x over by subtracting and combining it here. So I now have x to the third plus 2x squared minus 4x. I'm going to add 3 to the other side, minus 3 equals 0. And it actually turns my equation into a polynomial equation. Again, I'm going to erase it just to make a little bit of room. Solve polynomial equations. We're actually going to do synthetic division. My coefficients are 1, 2, -4, and -3. You can graph this, and I cheated a little bit ahead of time to see where the intersection point is, and I know -3 is going to work. So therefore, going through synthetic division, bring it down, multiply, add them together, multiply, add them together, multiply, and guess what? You get a 0 remainder. So therefore, one of my x values that works is actually -3. So my first points be -3 comma something. And I can plug that back into my original equation. Now that's going to be pretty easy. -3 squared is 9, 9 minus 3 is 6. There's your first point. The other 2 points, and the reason I say 2 points, because I know there's going to be 3 answers, possibly, comes from here. So I'm going to take that x squared minus x minus 1, and I'm going to use the Swinford method on it. I'm doubling everything since I do not have an even middle number. I'm doing opposite half, squaring that, and then the head is going to be -4. So my other 2 answers are actually going to be, I'm going to write them, let's see, I'll come over here and write them. It's going to be left leg plus and minus the square root of the difference. That's going to be 5, all divided by 2. And I've got those 2 typed in so I can get some decimal approximations, and here they are. Those x values are 1.62 and -0.62. And a lot of times you'll see some symmetry amongst those answers, and you see the 0.62s in both of them. And then all we're going to do to find the y values is just simply plug those x values back in. And when I do that, I get answers of, let's see here, -0.38 and -2.62. Okay, I wanted to show you this from that actual problem just because sometimes we forget what we're actually doing with these problems. So in blue on here on Desmos, here in blue you see the actual parabola, and then in red you see the other one. And those intersection points, what we just found were these 2 graphs actually have 3 different intersection points, and it's the exact same points that we found, and you can see those 3 points right there. Okay, number 6, let's do one more, and maybe this one will be a little bit easier. So you have y equals in the second one, y equals 5. And you do have a y value right here that we're going to plug that into. So we simply have now 5 equals 2 to the x plus 3 minus 5. This can be cleaned up just a little bit by moving that 5 over. So now we have 10 equals 2 to the x plus 3. Now anytime we're in this form, okay, to where you have x's up in the exponents, the only way we can solve this thing is we can try to turn 10 into 2 to a power, which we're not going to be able to because 10 is not does not have a base of 2. So I'm going to write this the other direction so it looks more like what we've been changing to log form. That's going to be log base 2 of 10 is equal to x plus 3. Move the plus 3 over by minusing 3. So therefore we get x is equal to this value, and I'm going to plug that into my calculator. And just a reminder, to plug that into your calculator, you can type that in as -3 plus, that's going to be, change of base will be log 10 divided by log 2. And you actually know log 10 is 1, so it doesn't matter how you type it in, but we now know that x has a value of about 1.32. So that's your x value, 1.32. To find the y value, we're going to plug that into either one. Now notice that second one is actually going to be a little bit easier to plug it in because there's no x there. It just says y is 5. So we know that my y value is going to be 5, and that's going to be your final answer.